over here we say that if B is k times of A, now it is so important that I need to write it bigger. I need to write it bigger, so I assume everyone write down as well. Start. No more revision. So this vector B with an underscore is equals to k times of A. This k is actually a number. For example, on top you see that this UV is negative 3 is a number of another vector. Then we say that they are what? Parallel. So once I can write this, there are two things I can say. The first thing is B is parallel to A. That's the first thing. Second thing is B has a magnitude that is k times of A. Now this k, you notice there's these two. What does these two means? This one means modulus. That means positive value. Now I give you an example. You may wonder, why so troublesome? Why must I put the modulus? Because I bring your attention back to this UV and PQ. Now look at UV. UV is where? UV is here coming down. Can follow? So I use a marker, I draw. UV is coming down. UV is coming down from top to bottom. But PQ is going up. Now, if I talk about the length, is it correct to say that this is 3 times of this? Yes. Do I need to say this is negative 3 times of this? No need. So therefore, below, if I have this negative only means direction. So over here, you look at this thing here. So I will say, B is k times of A. I don't care about the sign in front, because magnitude is just the length. Do you follow? Now let's go to some examples how to use this to solve question. 90% coming out, 90%. This is very high rate. Always come out. Now, let's start with the first one. Turn to the next page. What's the time, Travis? 2 minutes. 2 minutes only. So short. Okay. Now, these two vectors, are they similar? Now, how do I want to show that they are similar? So, you look at the first one. You want to make a guess whether they are similar? Yeah. But how to show? Factorize. Very good. So this, I factorize, I can take out a 2, bracket, this is 3, 4. Right? So since the two of them share the 3, 4, then they are parallel. How to present an answer? This is how you present, no? This is equal to this. Can you see? It's something like vector B is equal to 2 times of vector A. Can you see that? Follow? Am I confusing you? No. So this is my B, this is my A. So is B and A parallel? Yes. So how do you write? So this is how you write. Since 6, 8, the vector is equal to 2 times of 3, 4. 6, 8 and 3, 4 are parallel. I don't know whether you are copying or talking, because I hear background voice. Questa, done. The second one, is this parallel? Confusing because I want to use the same way to present. So the same way means I should have something, a number and 2 vectors like that. Now what you can do is you take this vector, divide by this vector. I show you. So then I write 8, negative 4, divide by 6, 3. Now if I take this vector, divide by this vector, it's actually the factorized form. 2, negative 1, this is negative 3, 2, negative 1. Do you follow what I say? What I'm trying to do is I'm trying to factorize the number out. And since they have 2, negative 1, 2, negative 1, what can I do to them? Cancel. I can cancel them away. Now, moving over, this is my first vector. This is a number, this is a second vector. Can I multiply the second vector over? Again, I multiply, this is denominator, right? I just multiply over, and it will look something like that. 8 negative 4 equals 4 over 3, 6, negative 6, 3. Who don't understand how I get this? Oh, there's a negative. There's a negative 3. Who don't understand this one? Don't understand. Okay, I show again. Now, what I'm showing you is I take one vector divided by another vector. Once I factorize, I notice that I can cancel them. Now, this bottom vector, I can actually bring over. Why I want to bring there? Because once I can write this, right, you notice that this looks like my red pen. This looks like B is equals to K times of A. Now, yes, you can switch anyhow you like. But what I want you to write is, because your friend mentioned presentation, how do I present? Once I can write one vector is equal to a number of another vector, what can I say about these two vectors? Parallel. Can follow? So since I can write this part is a bit troublesome, but write it down, then I can say that, oh, this vector must be parallel to this vector. Don't need to record, you can just watch the video. So how do you present the answer? Same thing. Since 8 negative 4 is equal to negative 4 over 3, negative 6, 3. Then you tell me 8 negative 4 and negative 6, 3 are parallel. Last one, C. So I made the presentation standard. I take two vectors, I divide. I can factorize one out. I cannot factorize the other. I cannot cancel. So I go ahead and write. Since this is not equal to K times of that, then the two vectors are not parallel. Okay? Watch the video. You can pause the video, then you slowly copy down. Example. Given that this and this are parallel, if they tell you they are parallel, the first statement is to write what? B equals to K times of A. Vector B is equals to K times of vector A. So how you will write? You don't write B and A anymore. You write 2, 5 is equal to K times of negative 6H. Yes. Why I write like that? This is something like your vector B is equal to K times of vector A. Follow? Why I can write like this? Because they are parallel. Okay. How do I continue from here? Now, this K multiply up, down, or both? Both. So which means I can write 2, 5 is equals to negative 6K and HK. Now I follow. So top number must be equal to top number, bottom number must be equal to bottom number. And therefore, I can write 2 equals to negative 6K, equation 1. 5 equals to HK, equation 2. So I base on top equals to top, bottom equals to bottom. So from here, you solve. I don't know. For you to find out. You will find out next Wednesday. Okay, go for lesson. Help me push in the chairs.